2 million years ago, something impossible happened. A skinny, slow, practically defenseless ape, with claws too dull to fight, teeth too small to tear raw hide, and a stomach too weak to survive on leaves and bark like its cousins, should have gone extinct. Instead, it became us. There is one reason, and only one reason. This animal survived long enough to build cities, write symphonies, and put a probe on Mars. It figured out how to steal a piece of the sun, hold it in its hands, and use it to break food apart before eating it. We didn't just discover fire. We did something no creature in 4 billion years of life on Earth had ever done before. We started eating what fire had already half digested for us. And according to a growing body of anthropologists, that single decision didn't just change our diet. It rewired our jaws, shrank our guts, doubled the size of our brains, and possibly even gave us language, laughter, and love. This is the cooking hypothesis. And by the end of this video, stop. You may never look at your dinner plate the same way again. Before we step into that first ancient kitchen, answer me this. If you woke up tomorrow and every stove, oven, and lighter on Earth had vanished, could you survive on raw food alone? Drop your honest guess in the comments. I read every single one. And if you love uncovering the hidden turning points that made us who we are, hit subscribe and tap the bell, because we post a new deep dive every week. This channel exists for one reason: to understand our past so we can navigate our future a little more wisely. Welcome to the family. Now, let's go back 2 million years. To understand why cooking mattered, you first have to understand how brutal life was before it. Picture Australopithecus, one of our earliest ancestors, waking up at dawn with one job: chew. Not for 20 minutes, not for an hour. Chimpanzees today, our closest living relatives, spend nearly half of their entire waking day chewing raw plant matter. Some estimates put early hominins at 4 to 6 hours of non-stop chewing daily, just to extract enough calories to stay alive. Raw food is a battle. A raw yam is closer to wood than to dinner. Raw meat is tough, stringy, and packed with collagen, your stomach acid barely dents. Raw wild grains are locked inside. Husks your gut cannot crack open. Chimpanzees have massive jaw muscles, huge grinding molars, and a gut nearly twice the relative size of ours, all dedicated to one task: brute forcing calories out of raw material that fights back the entire way down. Now, here's the experiment that changed everything. Take a raw sweet potato and a roasted one. Raw, it's dense, starchy, almost impossible to break down. Roasted, the heat ruptures the starch granules, softens the fiber, and turns the exact same vegetable into something your body absorbs almost effortlessly. That is the entire secret. Cooking is not about flavor. Cooking is pre-digestion. Heat breaks collagen into gelatin. Heat ruptures cell walls in plants and unlocks starches trapped inside. Heat does, in minutes, outside your body, what your stomach would otherwise need hours, or simply couldn't do at all, to do inside it. Which means every calorie our ancestors used to spend chewing and digesting suddenly became a calorie they could spend somewhere else. And somewhere else turned out to be the most expensive real estate in the entire animal kingdom: the human brain. Here's where the science gets genuinely wild. Your brain weighs about 2% of your total body weight, but it burns roughly 20% of your total daily calories. Even when you're doing absolutely nothing, even while you sleep. No other organ comes close to that kind of energy demand. A brain this expensive should not exist in an animal with a gut this small. Every other large-brained possibility in nature comes with a trade-off. And biologists call that trade-off the expensive tissue hypothesis. The idea, developed by researchers Leslie Aiello and Peter Wheeler in the 1990s, is elegant. Metabolically active tissue is costly, and animals can't just grow more of it for free. Something else has to shrink to pay the energy bill. When anthropologists compared the digestive tracts of primates, they found something remarkable. Humans have unusually small guts for our body size, almost 40% smaller than a chimpanzee's, relative to body mass. A smaller gut costs less energy to run. That saved energy had to go somewhere, and the leading destination was our rapidly expanding brain. But a shrinking gut can only work if the food arriving in it is easier to process. You cannot afford to downsize your digestive system while still eating raw, fibrous, calorie-poor plants and tough raw meat. That math doesn't work. It only works if something outside the body is doing part of the digesting first. That something was fire. Harvard primatologist Richard Wrangham, who literally wrote the book on this theory, Catching Fire, How Cooking Made Us Human, argues that cooked food isn't just softer, it delivers dramatically more usable energy per bite. Controlled studies, mice fed cooked meat gained significantly more weight than mice fed the exact same raw meat, even though the calorie count on paper was identical. The cooking itself was unlocking hidden energy that raw digestion simply could not extract. Multiply that extra energy across every single meal, every single day, for hundreds of thousands of years, and you get exactly the kind of caloric surplus a brain growth arms race requires. Smaller gut, bigger brain. Up. Cooked food is the hinge the whole trade balances on. The brain wasn't the only thing that changed. Cooking rebuilt us from the jaw down. Compare the skull of Homo habilis to Homo erectus, who shows up roughly 1.9 million years ago. Homo erectus has smaller teeth, a smaller jaw, and weaker chewing muscles than earlier hominins. Exactly what you'd expect if food had suddenly become dramatically easier to eat. Homo erectus also shows the first clear signs of a smaller rib cage and narrower pelvis, both consistent with a shrinking gut making room, quite literally, for other things to grow. There's an energy dividend too. Freed from 6 hours of daily chewing, our ancestors suddenly had spare time and spare calories. That surplus didn't just build brains. Some researchers argue it also fueled the extraordinary human capacity for endurance. Cooked food may have helped power the long distance, walking and running, that let early humans scavenge and eventually hunt across vast stretches of the African savanna. Chasing prey that couldn't outendure, a species that no longer spent its whole day grinding raw fiber between its teeth. In other words, cooking didn't just feed the brain. It freed the body. Skeptics used to say all of this was just a nice story with no hard evidence. Then the dirt started talking back. At Wonderwork Cave in South Africa, archaeologists found burned bone fragments and ashed plant remains dating back roughly 1 million years, deep inside a cave, far from any lightning strike, meaning it almost certainly wasn't a wildfire that wandered in by accident. At Gesher Beno Yaakov in Israel, researchers uncovered clustered, burned flint and wood dated to around 790. Zeros and years ago, arranged in patterns consistent with a controlled, repeatedly used hearth rather than a random blaze. Evidence like this doesn't prove cooking was universal that early, but it proves the technology existed exactly when our bodies started changing. Brain size, climbing, teeth, and jaws shrinking, guts getting smaller. The fossils and the fire pits are telling the same story from two completely different directions. Our meat left out in the African heat is a bacterial breeding ground. Parasites, Salmonella, E. coli, All of it thrives in raw, unrefrigerated flesh. Heat kills the vast majority of these dangers almost instantly. Anthropologists have called fire humanity's first antibiotic. Millennia before we understood germ theory, our ancestors were already sterilizing their food by accident. And every generation that did it lived a little longer and got sick a little less than the ones that didn't. But the deepest change fire caused wasn't biological. It was social. Before fire, primates eat where they find food, whenever they find it, usually alone or in small, scattered clusters, because there's no reason to gather anywhere else. Fire changed the geometry of daily life. You cannot carry a cooking fire around all day. You have to bring the food back to it. For the first time in the history of any hominin, there was a fixed point in the landscape. A hearth that everyone returned to at the end of the day. Think about what a hearth actually creates. A predictable time when the group is together. A predictable place where food is shared rather than eaten alone in a tree. A source of light that pushes the working day past sunset, giving early humans hours they'd never had before to do something other than survive, to talk. Richard Wrangham and other researchers argue that the campfire may be the true birthplace of human storytelling, of extended pair bonding, of the division of labor between gathering, cooking, and childcare. Some scholars even connect the predictable, cooperative structure of the shared hearth to the eventual emergence of complex language itself. You cannot coordinate a hunting story, teach a child which plants are poisonous, or negotiate who eats first without a shared, repeated, safe space to do it in. Fire built that space. And once we sat around it for a few 100,000 generations, we came out the other side as fundamentally social storytelling creatures. Here's the part that should genuinely surprise you. This isn't just a compelling story. It's measurable right now in your own body. Modern humans are, quite simply, the only primate on the planet that cannot survive long-term on a strictly raw diet in the wild. Studies of modern raw foodists, people who deliberately eat 100% uncooked food by choice in the developed world, with grocery stores full of soft fruit and modern kitchen tools like blenders, still show measurably lower body fat, and a meaningful percentage of women on long-term raw diets experience amenorrhea, the loss of menstruation, a biological red flag that the body isn't getting enough usable energy to safely reproduce. And that's with modern conveniences. Stop. Try to imagine doing it with nothing but your bare hands and a sharpened rock, the way our ancestors would have had to. Our jaws are too small, our molars too weak, our guts too short, and our stomach acid too mild to extract sufficient calories from raw wild food, especially raw meat and fibrous raw plants, to sustain a brain this metabolically greedy. We have, in a very real sense, outsourced part of our own digestion to fire. And we have been doing it for so long that our bodies quietly deleted the backup system. We are not just a species that cooks by preference. We are a species that cooks by biological necessity. It's written into the very architecture of our skulls, our stomachs, and our DNA. From a glowing ember in an African cave to the blue flame on your stove tonight, cooking is arguably the single act that separates us from every other animal that has ever lived on this planet. It gave us the spare calories to grow a brain we couldn't otherwise afford. It gave us the safety to live longer, healthier lives. And it gave us the fire-lit hearth where language, storytelling, and human connection may have first taken root. So the next time you're standing in your kitchen, waiting for something to finish cooking, remember what's actually happening. You're not just making dinner. You're repeating the exact same act. the one single habit that took a fragile, small-brained ape and turned it into the dominant species on planet Earth. Thanks for watching. Half evolved. If today's video sparked something in you, go check out our companion piece. What did humans eat before fire? Linked right there on screen and in the description. Stay curious, and I'll see you in the next one.